All right, you already see it in front of you, but we did addition and subtraction. What do you think the next thing is after addition and subtraction? It's multiplication and division. Exactly right. So that's what we are doing today. So there's a couple rules. This is actually a lot easier, I think, than addition and subtraction, the rules. Because addition and subtraction, you got to worry about like which one's the bigger one, and right, and you put the sign of the bigger one, and sometimes you add, sometimes you subtract. Sometimes that gets a little confusing. With multiplication and division, it's the same exact rule. The same rule for multiplication as it is division. All right, which is really kind of nice. So we have two scenarios. We have one scenario, put a 1 right here, where you have the same signs. We're talking about multiplying two numbers together, okay? Two numbers. We'll talk about multiple, more than two, towards the end of this, all right? But right now, we're just talking about two numbers. And if they have the same sign, whether you're multiplying or dividing, it does not matter, okay? The same signs, your answer is always going to be what? You probably know this already. You took Algebra 1. If I'm multiplying two numbers and they have the same sign, both negative, both positive, what's my answer going to be? What's the sign of my answer going to be? What is it? The same? The same as what? If they're two positives, it's going to be positive. Two negatives, it's going to be negative. To me, that's what it means to be the same. So let's do an example. I want you to think about it because I know you've done this. What is positive 3 times positive 2? What is that? It's easy. 6, yeah, positive 6, agreed? Okay, so when they're both positive, your answer is what? Positive. What if they were both negative? Your answer is positive again, that's right. Okay, so what is the rule? Same signs, if I'm multiplying or dividing, if I have the same two signs, what's my answer always going to be? It's always going to be positive. And that's all you got to remember. Really, really easy when you have the same signs. Okay? Everybody got it? So when they're both positive, your answer is positive. When they're both negative, your answer is negative. What about division? Remember I said the rule is exactly the same? So what if you did like 12 divided by 3? What's 12 divided by 3? 4. Positive, positive, right? What if I did this? What if I did negative 12 divided by negative 3? It's still positive, that's right, because they're both the same signs. See the rule? Same signs is always positive when you're multiplying and dividing. So same signs, it's still a positive 4. This is coming back to you? You learned this in algebra, didn't you? Yeah. Might have just forgotten. And that's fine. That's why we're doing this review. That's pretty easy. Oh, let me say one more thing about the fractions. Well, now let's not do that until we do the next rule. And we only have two rules. And again, they both apply for multiplication division. Two rules. So I could have two numbers that have the same signs. What's my other option? Different signs, exactly right. So let's write that down. So I could have two numbers that have different signs. Different signs. That means one is what? Positive and the other is negative. Okay? That's what it means by different signs. Positive and negative. So what's my answer then? What if one is positive, one is negative, and I'm multiplying or dividing? My answer is always negative. Exactly right. Good. Okay? My answer is always negative. So let's do it. Let's use the 3 and the 2 again. We got those already. So what if I had negative 3 times positive 2? What's my answer for that? Negative 6. Is it because the 3 is bigger than the 2? Is that why No. It's because they're just different signs, right? What if I did this? What if I did 3 times negative 2? What's the rule? Look at the rule. Different signs, the answer is always what? It's always negative. It's always negative, all right? Doesn't matter. Remember right here, I said just because the 3 is the bigger number is not why this is negative. That's not why this is negative. It's negative because one is positive, one is negative. They're different signs. Okay, the one where you did the biggest number, that was for addition and subtraction. Okay, remember that? So don't get them confused. make sure that you go back, you watch the other video on addition and subtraction, then watch this one, you'll see the difference. So 2 different signs is always negative. It does not matter if the negative is with the bigger number or with the smaller number. It makes no difference, right? You just have to know if one is positive and one is negative, your answer is going to be negative. The same thing works with division. Let's use the 12 and the 3 again. So what if I had this? What if I had negative 12 divided by 3? This is how we show division. By the way, I'm thinking about it, and I'll forget if I don't say it now. This is kind of the way we show multiplication nowadays, right? When you're a little kid, when the first time you ever did multiplication, how did they show it? What was the symbol? The X, right? So it was like 3 times 2, agreed? Then you got into, I don't know, middle school, you had pre-algebra. Then they introduced multiplication with a what? With a dot, right? And there's nothing wrong with that, okay? But we've outgrown the X, and in fact, most of the time, we've outgrown the dot, all right? There might be times where we use it, but most of the time, we do it this way. Or you don't even need them both in parentheses. What's another way you could write it? You could write the 3 and then just the 2 in parentheses, okay? So these are all different ways you could show 3 times 2. I really can't think of any other way. Well, unless you go, you wouldn't do this, okay? You rarely see this, like that, okay? If you saw just one of them being in parentheses, okay, it's always the second one. The first one's outside the parentheses and the second one's inside the parentheses. Everybody got that? Now, with that said, this worksheet that I'm going to give you today, they actually use the X, I think they use it for, towards the end, they start putting the parentheses there. They don't use the dots at all, okay, but they use the X all the time. I think it's kind of weird, but that's the way they do it. But when you get a math book, this is just a worksheet I got off the internet. When you get a math book, though, in an algebra on up, they'll probably always either put both in parentheses or put one in parentheses, all right? Every once in a while, they'll do the dot. They'll hardly ever do the X anymore. Okay, so say bye-bye to the X. Okay, we learned that when we were little kids, but we don't do that very often, except for this worksheet. For some reason, this worksheet, they put the X's on there. All right, enough of that. Same thing with division. When you're a little kid, what was the symbol for division? Yeah, the line with the 2 dots. Very good. Okay, that means division. Well, guess what they do on this worksheet? They do a lot of that symbol for division. Now, they also do the fraction like this. This also means division. All right, so if I said 12 divided by 3, what is that? That's 4, okay? Everybody see that? All right, now these are different signs. So what is negative 12 divided by positive 3? It's negative 4 because they're different signs. Again, it doesn't matter which one's a bigger number, all right? It's just the fact that they're different signs, okay? Same thing here. This negative 12 and the division symbol and the 3 means the same exact thing as this. This is like the big kid way of doing division nowadays, okay? When you're a little kid, you did this symbol. When you're a bigger kid and you go higher in math, they start showing division as a fraction. But again, this worksheet, they do like half and half. Half their division looks like this, half their division looks like this. You just have to know the difference, all right? And again, we did it already. What's negative 12 divided by 3? It's negative 4. Oh, by the way, I didn't say this in the other class, but that symbol, did anybody ever show you what that symbol means right there? This dot represents a number. All right, so let's do a different number besides 12 and 3. Let's go 6 and 2. All right, so 6. So that dot is the 6. You got your little fraction bar there. What's that dot right there? That represents a number. All right, let's go 2. So this division sign really means something divided by something else. They just replace that something with a dot on the top, and the something on the bottom, they replace that with a dot. Has anybody ever shown you that before? That's kind of interesting, isn't it? Did you ever wonder why division looked like that? That's why. All right, because this is the numerator, this is the denominator, that's your little fraction, That's where the division sign comes from. So that's a nice fun fact, isn't it? You guys don't seem that impressed with that. I thought that was pretty cool. All right, so I think I learned that in college. I don't think I ever knew where that symbol came from. Never really give it a second thought, didn't care. But I think a professor in college said, hey, do you know where that comes from? And I was like, whoa, that blew my mind. Anyway, just thought I'd throw that out there. All right, what if you had this? What if you had 12 divided by -3? That's still -4. Again, it doesn't matter which one's the bigger one. As long as you have one positive and one negative, that's what you care about. All right? Let me show you one more thing about these fractions that I think is important. I think a lot of people don't understand this. There's actually 3 ways to write -12/3. All right? There's one where you put the negative on the top. There's one where you put negative on the bottom. What's another way that I could write -12/3? That's right next to the line, right in the middle. So if I put it right here, and then I put a 12/3, that's still what? What's that equal to? That's still -4, okay? So you could put the negative on the top, could put it on the bottom, or you could put it right out front. All 3 of those mean the same exact thing. I've noticed that kids struggle with that. The many years that I've taught math, a lot of people don't really understand that it could be on the top, it could be on the bottom, or it could be right out front. It means the same thing. Everybody with me? Okay. Let's see. I know what we're going to do. Let's do this. And we're almost done, I promise. You don't believe me? I am. I'm almost done. So what if I had, I'm not going to put numbers in here. I'm just going to put negatives and positives. What if I multiplied more than just 2 together? All right? What if I multiplied the first one is a negative, the second one's a negative, this one's positive, and this one's negative. All right? So pretend there's numbers in here. Okay, I don't really care about multiplying the numbers together. I just care about the signs. So what is the sign of this answer after I multiply them together, Justin? How do you get negative? Okay, both these negatives right here, these 2 negatives make a positive. This is positive, 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 so those are all positive. Times a negative is what? Is negative. There's another way to look at it, and that's a good way to look at it. You did fine with that. Okay, but there's another way to look at it. How many negatives do I have? I got 3 negatives. I don't care how many positives I have. Count up how many negatives. 3 is what kind of a number? Odd or even? It's an odd number, okay? So when you have an odd number of negatives, your answer is always going to be what? It's always going to be negative. Odd number of negatives. There's 3 negatives. Your answer is negative. What if I had 4 negatives in there? It would be a positive. That's right. So let's write this down. So if you have an odd number of negatives, I'll just shorten it, that's going to give you a negative answer. Okay? If you have an even number of negatives, what's that answer going to be? It's going to give you a positive answer. Everybody good? So let's just do 3 numbers, make it really easy. What if I had -3 times +1 times +2? What's the sign of the answer going to be first? It's going to be negative because I got 1 negative. 1 is odd, isn't it? So my answer is going to be negative. I don't care how many. I could have 50 positive numbers here. All right, but if I only have 1 negative, my answer is going to be negative. Negative what in this case? -6. Okay. What if I had this, this, and this? What's the sign of the answer going to be for this? It's going to be positive. How'd you know that? Because it's even. All right, there's 2 negatives. That's even. All right, and so even means it's going to be +6. I'll just put a plus there just so you know. That's pretty easy to understand, isn't it? Yeah. And you probably already knew this. I'm sure your teachers have taught you that before. But again, we're just reviewing. We're just trying to make sure that you kind of remember this stuff because you're going to see this stuff in your geometry course. all right, you will be multiplying negatives and positives together. Later on, probably next week, we're going to start solving for x. Remember doing that in algebra, right? We're going to do a ton of that in geometry. We're going to do a lot. I mean, there's going to be a point where you're going to think, is this geometry or is this an algebra class? Because you do so much algebra in here, right? For some of you, that's great because you did great in algebra. For some of you, you're like, oh, I'm a little shaky on my algebra. Well, that's why we're taking this week and probably next week to review the algebra. Then we'll get into the geometry. And there are times where you don't do any math in geometry. You don't add anything, you don't subtract, you don't multiply, you don't divide. There are times when you don't do any of that stuff. But the further and further we go in geometry, the more and more like real math stuff that we actually start doing, okay? Any questions, any concerns of what we've done so far? All right, so I'll give you the rest of the time to work on this worksheet, and hopefully you can get most of it done, if not all of it. We'll see. All right, have a good weekend.